Good day, everyone. And once again, your favorite uncle is back. And today we'll be looking at linear inequalities. If you haven't subscribed, please just make sure that you're part of this family. And our family is growing. Just make sure that you also tell others. And, at the end of the lesson, please just leave a good comment. And obviously, we always will try to ensure that we respond to your comments as well. All right, so I want to get right into our lesson today without any further waste of time. Right, so we're talking linear inequalities, right? So, first of all, what is an inequality? Well, it's obviously when we've got equations, all right, we know that it is marked by an equal to sign, right? So, we know we've got an equal to sign. And what it tells us is that whatever is on the left hand side is equal to on the right hand side, right? But when we've got an inequality, we've got two signs, or well, four actually, which is the greater than sign. Okay, so if I say to you, x is greater than 5, all right, so in this case, it means that whatever the value of x is not 5, right? That value is bigger than 5, is any other value that is greater than 5, right? And of course, we've got a less than sign, and we're going to talk about it at length, right? If I say to you, well, whatever the value is, b is less than, let's say, 3 in that case, right? So what we are simply saying is that all values of b that can be included in this case must be less than 3, right? So as a result, those are the two values. Now I'm going to show you different types of notations, okay? But also, okay, we've got values where we've got inequalities that are, well, greater than or equal to. So we use something like this, right? So it's greater than or equal to. So if I say to you, x is greater than or equal to 5, right? So it means that 5 is also included as part of that solution, whereas in the previous one, it simply means it must strictly be any other value that is greater than 5 but is not 5, right? So it means we are including the value that we have here, all right? So if I took this one and say b is less than or equal to 3, so it means that b can be any value, right, from 3, which we are including in this case, as well as any other value that is less than 3. So meaning it can be 3, it can be 2, it can be 1, or whatever the value may be. Okay, right. Now, we're going to talk about different types of notations, all right, before we get into examples. And I want us to, I'm going to show you what we call the number line method, okay, as well as the interval notation, okay. Won't really go much into the set builder notation, but perhaps it might be worth mentioning later on. Right, now, I want us to talk about in this case, so if I say to you, okay, let's say x is less than 5, okay, so we made that example. Right, now how would we represent this on the number line? Okay, so we take the number, okay, we put it on the number line, and we say, well, if this is the number 5 on our number line, it means if we say x is less than, okay, so this is less than, okay, so if I say x is less than 5, it means x can be any value from from 5, or anything less than 5, that is. So what we do is when that number is not included, we use just in practice, we use just an open sign there. It's like an O that you use there to show that we haven't included 5, right? Or we can say it's an open dot, right? And any other value that is less in this case would be applicable, right? So in this case, it simply means that x is any other value that is less than 5. Now think about it. When you go on and on and on and on, all the way, in this case, you end up at what we call negative infinity, isn't it? Okay, so you can keep going and going and going all the way to the negative signs, all the way to negative infinity. So how do we write this as an interval notation? We simply say, well, in this case, now remember, when we write it in interval notation, we always start from the smallest value to the to in ascending order, from the smaller to the bigger value, right? So how we write it in notation, in interval notation, we say therefore x is an element of. Now please, I want you to note, I'm starting from the smaller value. Remember that negative infinity is the smallest value, and I ascend going that way. I'm increasing going that way. So from negative infinity. Now, we never include, when we use round brackets, we simply mean that that value is not included, right? So we never include, negative infinity in this case. Why do we not include it? Because remember, negative infinity is not a definite value, right? It means that the numbers just go bigger and bigger and bigger. Now, if you think about it, what's the biggest number that you can think of? Okay, I'm sure you've got one in your imagination. But remember, that big number that you have, I can add 1 to it, right? So where is negative infinity? It's a value that's really not, it's not there, right? Because it's just numbers going bigger and bigger and bigger, right? So in this case, we're saying from negative infinity all the way up until 5. But in this case, 5 is not included. How do we see that? Because in this case, we said less than 5, right? So if it's not included, we use a round bracket as well. I hope that makes sense, ladies and gents. Right, now, I want us to quickly take where we've got a greater than sign. So when we've got a sign that says greater than, okay, so let's say for instance, we take x is greater than, all right, let's say just for instance, minus 3, right? So what am I saying? I'm saying x can be any value that is greater than negative 3. So again, in my number line method, what am I going to do? I'm going to draw my number line. Okay, there is negative 3 over there, right? And I am simply saying that x can be any value, but it cannot be negative 3. It can be any value that is greater than negative 3. Okay, so there it is in my number line method. So in this case, so let me just indicate that that's a number line, that's a number line. All right, so what is it telling me? That it's going to be all values of x that are greater than negative 3. So how do I represent that in interval notation? I'm going to say, well, x would be an element of negative 3. So from negative 3, remember we said we write it in ascending order. And if we keep increasing and increasing and increasing, we don't end up at infinity, but it goes on and on and on, and we represent that by the sign infinity, right? So I'm going to say x is an element of from negative 3, which is the smaller value, right? And I'm increasing going that way, right? All the way. By the way, I'm using round brackets again, so it's telling me that I am not including that value, right? All the way until infinity in this case. And again, infinity is never included because it isn't a definite value, right? So that is how we'll use greater than, right? But of course, we just spoke about when we use the symbol less than or equal to, okay? So this simply means this is less than or equal to. All right. So what does that mean to us? Okay, let's take a value. Let's say if we say x is less than or equal to -6. Okay, what does that mean to us? It means for all values -6, from -6 all the way down, those values are going to be the solution. So in this case, we're going to write it as, in interval notation. What does it mean? So we're going to take our number line again, okay, and we're going to say, right, so if this is our number line, right, and this is our value -6, okay, so the solution for the values of x is from -6. Now we include -6, and what we do is we're going to write a dot there that is filled in, right? So unlike in the previous case where we have that dot that has an open space inside, but here we fill in that dot and it says x is all values from -6 all the way up until -infinity, right? But in this case, remember, when we write it in interval notation, what this simply means is that we're going to say x is an element of, remember we said when we go on and on and on, we'll end up at -infinity, right? Sorry about that. So that's -infinity, right? So in this case, we're going to say, well, but we write it in ascending order. Remember, -infinity is much smaller. With your negative numbers, they get smaller as you go towards the left, right? So in this case, we're saying x is an element of -infinity. We never include -infinity because it isn't a definite value, right? All the way up until -6. Now, please, I want you to note, because we said less than or equal to -6, it means that -6 is included as part of your solution, and so as a result, we use a square bracket for that. So the square bracket represents values that are included. I hope that makes sense to you, right? And then we said we can use a sign that is greater than or equal to. So this means we have a sign that is greater than, okay, so greater than or equal to. Okay, sorry for squeezing that in there, right? So that's greater than or equal to. So what does that mean, right? If we say, well, x is greater than or equal to, okay, let's just take any other value, greater than or equal to 4, right? So what does that mean in this case? It means that 4, from any value from 4 all the way up, that is part of our solution, right? So when I draw it into a number line, right? So there's a number line there. Okay, so we're saying any value from 4, let's say there's our 4 there, okay? And we are taking the solution from 4 all the way up, okay? And if we continue, we say all the way up until infinity. So remember, when you keep going and going and going, the numbers get bigger and bigger. And as a result, how do we write this in interval notation? We say x, therefore, is an element of, right? Remember, it's in ascending order. We say from 4, which is now included because we said greater than or equal to 4. So from 4, which is included, all the way to infinity, which is not included. Okay, so I hope that makes sense. There is another notation, ladies and gents, they call it the set builder notation, and how they represent that, say for argument's sake, if we were to take this, we would write it, in those special brackets there, and we say, well, x would represent values between x is less than 6, negative 6 for this one. Okay, right. It isn't far different from, less than or equal to in this case, right? So it isn't much different from this, except now you're using these very fancy brackets over here. And of course, you are mentioning that you are talking about values of x, right? That is why I won't really waste time on it. Okay, so what I want us to do is to look at some examples on linear inequalities. All right, now let's look at the examples that are following. Right, now in this case, what do we have? We've got x minus 2 is greater than 0. So I'm going to start with this first one. Of course, the question would be solve for x, right? If you've got this following expressions. Right, so I'm going to start with the first one. And we've got x minus 2 greater than 0. So what does that mean? It means that x in this case would be greater than, so we take the 2 to the other side, so that would be x is greater than 2, right? But how do we write this, how do we write this, obviously in the other format, right? We did say that we also need to incorporate that every time that we have a look at this, right? So we would say, well, x in this case would be, so first of all, let me draw the number line. So it means if we were to draw the number line again, right, we're saying for all values from 2 all the way up until infinity, right? So I'm going to just show you that. So from 2, but remember we are not including it, all the way up until infinity, right? Those values are acceptable, right? So we're using our interval notation in this case. So what are we saying? We're going to say, well, it means that x is any value. X is an element of. Now note from 2, we're saying that's not included. 2 is not included all the way up until infinity. I hope that makes sense to you, ladies and gents. So we're saying if you keep going, you'll end up somewhere in infinity. And sorry for not writing the arrows to indicate that that's a number line, right? So that is how the cookie crumbles. Okay, right, let's take the next one. So the next one says we've got minus 3x plus 6. So something very important there. Minus 3x plus 6. Okay, that is less than or equal to 0. All right, yeah, let me just make sure that we've got that correct. All right, now ladies and gents, I want you to please be very careful. Once we've got a negative sign, it means we need to multiply by that negative sign that is in front of our x value, right? So I'm going to multiply everything by negative, so it means that everything will change sign, right? So it means I'm going to have 3x minus 6. But remember, once I multiply by a negative, the inequality sign changes. Can you see it was less than? So now it's going to change to greater than or equal to, okay? 0, right? So now I've got 3x. As I continue, this is going to be 3x is greater than or equal to 6. All right, and of course we're going to divide by 3 on either side. So what do I have? X is greater than or equal to 2. Okay, 6 divided by 3 is going to give us 2, right? So it means in this case, what I'm going to simply do, if I write it again, an interval notation, right? So what I'm going to do is draw a number line and say, well, for all values from 2 all the way till infinity, right? Notice because 2 is included, I'm going to fill in that dot, in this case, all the way till infinity, right? So in this case, it means that when I write it in interval notation, x would be an element of, right, from 2, which is included, all the way up until infinity. And remember that we never include infinity, right? Okay, let's go on to the next one. Number 3, we've got 2x minus 3, which is less than 6. So that's 2x minus 3, which is less than 6. Okay, so we're going to do the very same thing again, right? So we're saying in this case, just to verify there that we've got the right thing. Yes, we do, right? So we're going to say, all right, so we've got 2x, right? I'm going to take the 3 to the other side. So would be less than 6 plus 3, right? So remember, when I take it to the other side, it changes sign. So that becomes 9, right? So I'm going to divide both sides by 2. So I end up with x is less than 9 over 2. 9 over 2 rather. Okay, so that's 9 over 2. So as a result, what happens? All right, I'm going to write this in inequality form. That's how it is. But in, in interval notation, I'm going to write the 9 over 2 there. So it means that in this case, remember, 9 over 2 is not included. So that would be our egg there. And we're saying all the way down up until negative infinity, right? So it means for all values of x, it's going to be all values that are less than 9 over 2. So x would be an element of negative infinity. Remember, we write it in ascending order all the way up until 9 over 2. All right, and 9 over 2 is not included, so we're going to use a round bracket. All right, so the very last one, okay, we're going to have there, we've got x plus 3 greater than 2x minus 5. Okay, so that's x plus 3 greater than or equal to 2x minus 5. And let's try and solve that together. All right, so I'm going to isolate, similar terms. So I'm going to take the 2x to the other side. So I'm going to have x plus, or rather, it's going to change the sign. So that will be x minus 2x. All right, now I'm going to take the 3 to the other side. It's greater than or equal to. So remember, I had negative 5 over this side. I'm going to have another minus 3 because it changes sign when it gets to the other side. And what happens? So I end up with x minus 2x, which is minus x, all right, greater than or equal to negative 8, right? Now, what happens? So in this case, I'm going to say multiply by the negative, so it's going to be x is less than or equal to negative 8, right? Now remember, we said positive 8 rather. So I'm going to so that is x. So when I multiply by negative, we said the inequality sign changes. So x is less than or equal to 8. So therefore, what happens in this case? If I write it in interval notation, again, where's my number line? It's telling me, well, from 8, okay, which is included, I'm going all the way down till negative infinity. Okay, all the way till negative infinity. That's my number line. Okay, so I'm going to say x is an element of negative infinity. Remember, we never include it, all the way up until 8 in this case, and 8 is included, so we use a square bracket for that. All right, that is how the cookie crumbles, ladies and gents, and I want you to try this one on your own, and please just comment and tell me what you get as your final answer. So I'm going to take x minus 4 which is greater or equal to minus 3x minus 6. All right, please just try that one on your own and then let me know what you get. Otherwise, from me for now, I'll see you guys next time, and we'll be touching on quadratic inequalities. Okay, please don't forget to subscribe and like and share and tell as many people that your favorite uncle is doing the most. Otherwise, I'll see you guys next time. Bye bye.